Students, in this presentation, we will see the selection sort, which is the ninth program in the syllabus. This is a problem statement. Design, implement C or C++ program to sort a given set of integers elements using selection sort method and compute its time complexity. Run the program for varied values of n. You give value more than 5000 to get at least a viewable number, otherwise it will be very small, and record the time taken to sort. Plot the graph of the time taken versus n. You vary the value of n, so you take 100, 1000, 5000, all those things, you note down the time. The elements can be read from a file or it can be generated using the random number generator, but here use a random number generator concept. Okay, now for the purpose of printing before sort or after sort, you can use routine like this. This is a logic. Assume that you'll be given 5 elements, 5 data items, 64, 25, 12, 22, 11 with index 0, 1, 2, 3, 4. Here the n value is 5. Now in this selection sort algorithm, you have to repeat this till n minus 1 times. You are always 1 less than n. The program goes like this. You start from 0th index. You'll be assuming that the first element, like you'll be assuming that this is the smallest element. Its index 0. You will be assuming that this is the smallest element. We don't know whether it is the smallest element, that we don't know, but we start with that assumption. Go and compare this element with the next element till the last, like 6425, 6412, 6422, 6411. When you compare that, whenever you see that smallest element, you just note down that index. So, like 6425. Now 25 is the smaller, note down that index 1. Next element 6412 compared. This is less than that, so note down it. The index now is okay 64. When you compare till the end, you get one smaller number. Till here it is 12. Then no change. 11. 11 is the smallest element. When you get that index, here the index is 4. You have to exchange. You have to interchange. You have to swap 11 and 64. That completes that first iteration. So after the completion of the first iteration, this highlighted number becomes a part of the sorted and remaining in the unsorted. Again you proceed this one. Now you start with the second element, second index I equal to 1. Assume that in the second iteration, no, the element 25, you assume that is the smallest element. You compare 25, 12. 12 is the smallest. Note down it like that till the end. When you complete it, no, you'll get the index of the smallest element. Once you get the smallest element after the completion of that iteration, interchange that. Here in this case, 12 and 25 are interchanged. In the third iteration, I equal to 2. So this is the starting element. This is the assumed minimum element. Its index is 2. 25 and 22 are compared. In these two, 22 is the smallest. Note down that index. Proceed. So whenever you see that the smallest element, that two element you interchange. So this becomes a part of the sorted. As there is only one element left, so no meaning in comparison, no meaning in proceeding. That is why. So we have to stop this process 4 times. As you can see, I equal to 1, I equal to 0, I equal to 1, 2, 3. So in 4 iterations, we will get the result. So this is the concept behind in selection sort. We'll go through code one by one if you want. So repeat till n minus 1 times. This is the assumed main index of the first element in the unsorted part. This is the unsorted part at the beginning. Its index is I. In this case it is 0. Okay. So you proceed from the next element onwards till the end. I equal to 1. J equal to I plus 1. From the next element in the unsorted part. We started from the first element of the unsorted part, that is the minimum. From the next J equal to I plus 1 till the end. you have to proceed. You always compare that A of j equal to A of min. Right now 64, 25 are compared. 25 is the smallest element, its index is 1. So min value earlier it was 0, now it is 1. Okay, A of min will give the element this the thing. So this is done till the end. Once we reach end, like 6425 are compared, 6412 are compared, 6422 are compared, 64 1 are compared. When you do like that, you will get the index of the smallest element. In this case, index of the smallest element is 4, its number is 11. Now in the next step, you have to swap. 64 and 11 should be swapped. You store that in temp. Okay, so this is the swapping. Swapping is done after the iteration, after the completion of that pass. So this whole process takes 4 iteration or n minus 1 iterations, n minus 1. Okay, this is the logic. Read the array size, declare the array, use random number generator concept. You adjust that number, take on the integer part, print the array, note on the starting time, call the selection sort by sending array and size, note on the end time, print the array, display this time. You repeat this for say 100, for 1000 values, for 5000, say maybe 10,000. Note on the values. You plot the graph. So here n versus time you can plot. This is the concept of selection sort algorithm. Thank you.